Welcome to Two Projects. In this video, we are going to explain the project Unemployment Rate Prediction using Machine Learning. Introduction. Utilizing cutting-edge data analysis and machine learning techniques, the project seeks to address a significant economic and social issue. Accurate forecasting of unemployment trends is crucial for policymakers, businesses, and people alike because it is a key indicator of a country's economic health. With the help of cutting-edge machine learning algorithms, we explore historical employment data in this project to create predictive models. Our goal is to present a powerful tool for forecasting unemployment rates by investigating various economic factors, labor market conditions, and demographic variables. With this project, decision-making could be improved, workforce planning could be helped, and overall economic stability could be increased. Objective of the project. The goal is to develop a reliable machine learning system for predicting the unemployment rate. Data exploration, processing, and visualization are the first steps, providing information on the economic factors affecting unemployment. The data is prepared for predictive modeling techniques like MLP, gradient boosting, voting regression, and LSTM through label encoding and feature selection. Time series forecasting techniques like ARIMA-based auto-regression and exponential smoothing are combined. Additionally, user registration and input for prediction are made possible by a Flask framework with SQLite. The final results are presented using a user-friendly front-end, and with this project we hope to give policymakers, companies, and people alike a useful tool for deliberation and economic stability. Requirements. These are the requirements needed to execute this project. Hardware requirements: operating system of Windows, processor of i5 and above, RAM of 8GB and above, hard disk of 25GB and above. Software requirements needed are Anaconda 3 and Visual Studio Community version. Now we'll discuss the flow of work. These are all the steps followed to build this project. The first step is importing required packages. This step involves importing required libraries and packages like NumPy and Pandas for data manipulation, TensorFlow for developing deep learning models, sklearn for machine learning tools and metrics, and Matplotlib Seaborn for data visualization. The second step is exploring the data set. In this step, we employ exploratory data analysis to better understand the data. The third step is data processing. In this step, we clean, transform, and prepare the data set, ensuring it is suitable for subsequent machine learning tasks. The fourth step is visualization using Seaborn and Matplotlib. In this step, we employ Seaborn and Matplotlib to create visual charts and graphs, facilitating a better understanding of dataset characteristics. The next step is label processing. In this step, we employ a label encoder to convert categorical labels into numerical values, enabling machine learning models to work with them effectively. The next step is feature selection algorithm. In this step, we select relevant features from the dataset and append them to create two datasets, X and Y. X is features and Y is target. This prepares the data for machine learning model training and prediction. The next step is data splitting to train and test. In this step, we segregate the dataset into training and testing subsets. The training subset is used for model learning, while the testing subset evaluates the model's performance on new data. The next step is building the model. We have used various machine learning and deep learning models in this project. The first model used is MLP, that is multi-layer perceptron. MLP is a type of artificial neural network known for its deep architecture. It is used for both regression and classification tasks. It consists of multiple layers of interconnected neurons, allowing it to capture complex patterns in the data. MLP is suitable for capturing intricate relationships in economic data, making it valuable for forecasting unemployment rates. The second algorithm used is gradient boosting. Gradient boosting is an ensemble learning method that combines the predictions of multiple decision trees to improve accuracy. It builds trees sequentially, with each tree focusing on correcting the errors of the previous one. It is effective for handling complex nonlinear relationships and capturing trends in the unemployment rate data. The next algorithm used is voting regression. Voting regression combines the predictions of multiple regression models such as gradient boosting and random forest and outputs the average or weighted average of their predictions. It leverages the strengths of both models to enhance prediction accuracy by reducing bias and variance. The next algorithm used is LSTM. LSTM, that is long short-term memory, is a type of recurrent neural network designed for sequence data. It is particularly effective for time series forecasting as it can capture long-term dependencies in sequential data. It is used for time series forecasting of unemployment rates considering the temporal nature of economic data. The next algorithm used is time series forecasting methods. Time series forecasting methods like exponential smoothing and auto-regression ARIMA are specifically designed for predicting future values in time-ordered data. Exponential smoothing focuses on weighted averages of past observations, while ARIMA considers auto-regressive relationships. These methods are essential for modeling and forecasting unemployment rates over time, accounting for seasonality and trends. The next step is training and building the model. In this step, we employ the preprocessed dataset to train previously mentioned models. These models learn data patterns and relationships. Subsequently, we evaluate model performance on a separate test dataset. This evaluation step helps ensure the models are accurate and reliable for real-world use. The next step is Flask framework with SQLite for sign-up and sign-in. In this step, we implement a web framework using Flask and integrate an SQLite database for user registration and authentication. Users can sign up by providing their information and subsequently they can securely log in using their credentials. This enhances system security and allows for personalized user experiences. Later, users provide input which is then pre-processed to prepare it for prediction. The trained models are utilized to make predictions on the pre-processed user input and the predictions are displayed through a front-end interface. So this is the horizontal bar graph in which on x-axis I have R-squared and on y-axis I have algorithm names. And we can see the voting classifier has secured good R-square score when compared to other models in this particular project. We will be using this algorithm for predictions. Execution of the project. To execute this project, first we need to open the code folder which contains the project source code files. So this is the static folder. This folder consists of files related to CSS, JavaScript and Bootstrap files. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is the app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. This is the model file which contains algorithm information. This file can be loaded into the project code during runtime to utilize the trained models. This is the notebook.ipynb file. This is the Jupyter notebook file which contains a combination of code, graphs and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. This is signup.db file. This file is the database file used to store user information. And this is the trained dataset and this is test dataset. Now copy the path of the code folder from the address bar of the file explorer. I'm copying it. Open the Anaconda prompt. Use the cd command followed by space and then paste the copied path and hit the enter button. This command is used to change the current directory of the code folder's path. So now compile the app.py file using the command python app.py. I'm typing python space app.py and hit the enter button. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, the Flask framework will host the application locally at the default address and the port unless configured differently. Now copy the local link provided by the framework. I'm copying it and paste it into any web browser. I prefer Chrome. After pasting it, hit the enter button. So this is the home page of the project displayed in the browser. This is the front end built using Flask framework. And here we can see a sign up button. Click on sign up button. So if we are new users, we have to register first, fill in all these details and click on submit button to sign up. And if we already have an account, we can directly sign in using the credentials. Click on sign in button. So give the credentials here. I'm giving my credentials and click on submit button. So it has redirected us to the unemployment prediction page. So here we can see these input boxes where we have to give the following inputs. Region. This denotes the geographical area for which we seek unemployment rate predictions. Frequency. Here we have to choose the desired frequency of unemployment rate estimates. Estimated employment. Here we have to input the estimated employment data. Estimated labor participation rate. Here we have to enter the estimated labor participation rate. This is the region type. From here we have to select the region type south, north, east or west, and longitude and latitude. Here we have to provide geographical coordinates. So we'll fill all these details now. The region is Andhra Pradesh. Select the frequency. Give the estimated employment. Give the estimated labor participation rate. I'm giving it as 41.02. Select the region type. I'm selecting it as south. Enter the longitude. I'm giving it as 15.9. Give the latitude. I'm giving it as 79.7. After filling in all these details, click on submit button. So here we can see the outcome. The predicted unemployment rate is 6.9% for the state mentioned. So it has predicted the unemployment rate for the mentioned state, that is Andhra Pradesh. Similarly, we can input other details and get the unemployment rate predictions for each region. So click on home. Now we'll fill in all these details again. So the region I'm selecting this time is Karnataka. Select the frequency. Estimated employment is 24215057. Estimated labor participation rate, I'm giving it as 47.29. Select the region type. I'm giving it as south again. Enter the longitude. I'm giving it as 15.3 and give the latitude. So after filling in all these details, click on submit button. So here we can see the outcome. The predicted unemployment rate is 5.49% for the state mentioned. So similarly, we can give inputs and get the unemployment rate predictions for each region. Now click on sign out button to sign out. So the conclusion here is, the project developed a thorough system that includes data processing, feature selection and a wide variety of machine learning models like MLP, gradient boosting and LSTM. Practicality is increased by adding time series forecasting techniques and a user-friendly Flask frontend. It is a useful tool for decision makers, companies and people who are interested in learning about trends in unemployment. The project's accomplishment in producing an effective tool for well-informed decision making and economic stability is demonstrated by the voting classifier's strong performance.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.